And what is striking, really remarkable, that this is independent of the amplitude, and it's also independent of this angle phi, this phase angle. What is this business of this phase angle? It's a peculiar thing that we have there. Well, you can think about the physics, actually. When I start this oscillation, I have a choice of two things. I can start it off at a certain position, which I can choose. I can give it a certain displacement from 0 and simply let it go. But I can also, when I let it go, give it a certain velocity. That's my choice. So I have two choices: where I let it go and what velocity I give it. And that is reflected in my solution, namely that ultimately in the solution I get the result of A and the result of phi, which doesn't determine the period, but it results from what we call my initial conditions. And I want to do an example whereby you see how A and phi immediately follow from the initial conditions. So in this example, I release the object at x equals 0, at t equals 0. So I release it at the equilibrium. At that moment in time, I give it a velocity which is minus 3 meters per second. My units are always in MKS units. The spring constant K equals 10 newtons per meters, and the mass of the object is 0.1 kilogram. And now I can ask you, what now is x as a function of time, including the amplitude A, including the phase angle phi? Well, let's first calculate omega. That is the square root of k over m. That would be 10 radians per second. The period t, which is 2 pi divided by omega, would be roughly 6.28 seconds. And the frequency f would be about 0.16 hertz. So just to get some numbers. 1.6 hertz, sorry. This is not my day. This is 0.628, and this is 1.6 hertz. 2 pi divided by omega, you can see this is 10. 6 divided by 10 is about 0.6. All right, so now I know that at t equals 0, x equals 0. So I see my solution right there, right here. I put in t equals 0, and I know that x is 0. So I get 0 equals a times the cosine of phi. Well, a is not 0. If I release that thing at equilibrium and I give it a velocity of 3 meters per second, it's going to oscillate. So a is not 0. So the only solution is that cosine phi is 0, and so that leaves me with phi is pi over 2, or pi is 3 pi. Phi is 3 pi over 2. That's the only two possibilities. Now I go to my next initial condition, that the velocity is minus 3. Now here you see the equation for the velocity. This is minus 3 at t equals 0. So minus 3 equals minus a, and a is, we don't know yet, minus a. And there we have omega squared, which is 10. T is 0, I get the sine of phi. If I pick pi over 2, then the sine of phi is 1. And so you find immediately that a equals plus 0.3. And so the solution now, which includes now phi and a, is that x equals plus 0.3 times the cosine of omega, which is 10t plus pi over 2. So you see that the initial conditions, what the conditions are at t equals 0, they determine my a, and they determine my phase angle. If you had chosen this as the phase angle, 3 pi over 2, that would have been fine. You would have found a minus sign here, and that's exactly the same. So you would have found nothing different.